We're going to take a look at two more parts of triangles here, and those two parts are the median and the altitude of triangles. So unlike angle bisectors and perpendicular bisectors, I can have those parts not actually be part of a triangle. You know, an angle bisector is just a bisector of an angle, and perpendicular bisector can exist just on a single segment, but medians and altitudes actually have to exist as part of triangles. So what a median is just a segment that goes from a vertex to the midpoint of the opposite side. So what I mean by that is if I have a triangle, here's just a triangle here, it goes from one of the vertices to the midpoint on the opposite side, so the point that divides the other side into two congruent parts. So this would be my median here, and so it has this property that it can have any angle with this opposite side here, just as long as it goes through its midpoint and then goes through the opposite vertex. So really it's a segment that connects 2 points together and really has nothing to do with the angles that are created. And so then the second one here is what's called an altitude, and it's the perpendicular segment from a vertex to the line that contains the opposite side. So if I have a triangle, draw another triangle here, the altitude will go from a vertex and then make a right angle with the opposite side. And so there's a couple important things that we need to touch on here. So we'll notice the fact that it says, let's see, from a vertex to the line that contains the opposite side. So the question is, why do we say that? And so in this case, obviously, it just goes from this vertex to the opposite side and makes a right angle. But I can have some situations, kind of like this first triangle that I drew. Let me draw another one, where the altitude won't exist in the way that you think that it will. And so if I want to go from this vertex to the opposite side and make a right angle, well, there's no segment or line that I can draw to the opposite side. However, if I were to extend this opposite side out, I can end up making a right angle with this opposite side. So the altitude here is a little bit unique because it doesn't have to always be inside of the triangle like the median. Then there's nothing I can do to take the median and kind of move it outside of the triangle. No matter how I move this around or rotate it or change where these vertices are, it's always going to stay within inside the triangle. But my altitude, that is not the case. And so there's a particular set of triangles that the altitude will be outside of it, of which of course will be obtuse triangles, where my altitudes end up existing outside of the triangle itself, which is interesting. So these are two new segments that exist inside of triangles or outside of triangles, but they are particular to triangles themselves here. If I'm just talking about having a segment, having a median of that segment doesn't make any sense. It only makes sense to talk about a median in terms of a triangle. So just one more time, a median goes from a vertex and makes to the midpoint of the opposite side, so it connects those 2 points, divides it into two congruent parts, versus my altitude goes from a vertex and makes a right angle with the opposite side. And so it doesn't necessarily divide this into congruent parts or anything, it just makes a right angle with the opposite side. So these are two more parts of triangles that we're going to take a further investigation into, but we'll have some interesting things that will result when we construct multiple of them.